I'm Jeff Browning with EMC. Shameless plug for my blog. Those of you who haven't heard of my Oracle Storage Guy blog, please Google Oracle Storage Guy and have a look. Without further ado then, we'll get started. There's the agenda. Spend a little time talking about the whole Joe Tucci keynote with the impending data explosion and how that impacts the Oracle market. Look at internal versus external clouds, approaches to actually implementing an Oracle database cloud. I have a common usage case set, including an actual case study here with my customer Steve Tout. By the way, Steve is responsible for all identities that are created on VMware.com and VMworld.com. So try to keep his beeper from going off by not logging in right now, please. Then I'll get some best practices and we'll wrap up. All right, so all of you have undoubtedly seen the Joe Tucci keynote where he shows this little dot representing the current data set, which is 0.8 zettabytes. And expanding to 2020, we get to 35 zettabytes, which is a 44x increase in data. So that's what's coming at us. Now, the interesting part of this is, at the moment, according to IDC DataQuest, 90% of the data in the world is unstructured data. It's file data. By 2020, the same time frame, 90% of the data will be structured. Now, why is that? What are we doing that's creating this data? It's Facebook, it's smart phones and PDAs and e-readers, it's smart meters, digital imaging for medical and dental, blah, 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 blah. All of that, without exception, virtually is structured data. Now, what does that mean to the DBA? That means that the amount of data explosion that will occur between now and 2020 is going to be a lot more than 44x. And unfortunately, also, DataQuest IDC has predicted that during the same period, the number of Oracle DBAs will only increase by about 40%. So we're going to have a 44x increase in data explosion, largely focused on databases with no real appreciable increase in staffing. That's what we end up with. All right, now, undoubtedly, a lot of this data, particularly in the Web 2.0 environment, the social networking, that will go on to all of these various database 2.0 vendors. But we can't count out Oracle, right? And I'll talk about why that is. A lot of this data is going to end up on Oracle databases. So there's a great film called Princess Bride by Rob Reiner. Undoubtedly, many of you are familiar with it. And in this film, the main character, Wesley, is captured by a character called the Dread Pirate Roberts. And every day during the 5 years he spends with the Dread Pirate Roberts tells Wesley he's going to do something to him. Does anybody remember what that was? He's going to kill him. He says, "Good morning, Wesley. And how you doing? I think I'll probably kill you today." Next day, "Hi, Wesley. I think I'll probably kill you today." So for 5 years, Wesley deals with impending death. That's what I call the Wesley state, right? Oracle DBAs are going to enter that state during this coming decade. They're going to come into work every day, and their database is going to sit there and look at them and say, "Hello, DBA, I think I'll probably kill you today." Now that will create a fundamental mind shift in how we do things. There is no way around that. If DBAs continue to work the way we are working now, we will die. Okay, that's just the way it is. So, there's two ways to go. One I've already mentioned, the external database 2.0 external cloud play. There's tons of those. You can Google it and read about them. I have no idea who's going to win. Microsoft is a big player. Apache has their play, and then there's a bunch of startups. The internal cloud is an interesting play for Oracle, and let me show you why that's true. So this is an Oracle shop. We have database servers, app servers, and web servers. something like e-business suite or like what Steve will be presenting on later. We have a tendency to have these increase in orders of 3. So, for example, when we add another set of 3 web servers, we tend to increase our app server by 1. We add another 3 web servers, we increase, and then once we get past 3 app servers, we add a database server, and so on. We are now arithmetically growing. This is the normal state that we've been up to now. Now, we get to the point where our web server farm exceeds the capacity of our traditional data center. And at that point, we do the normal thing. We go to a co-hosting location, and we shove our web farm out to that location. But we haven't, there's no cloud here. We're still on physically booted servers. Everything is very conventional. Now we continue to scale, increasing web, increasing app, until, now our app server farm has exceeded the capacity of our traditional data center. And our web server farm has exceeded the capacity of our service provider. Okay, so we're going to send our web server into the external cloud. This is a very common and normal event right now. A lot of people are taking their web server farm and sticking it in the cloud. Maybe then they put the app server farm in the cloud too, or maybe they stick it out on the service provider. Now we can accelerate. We're growing faster. We're increasing capacity much more quickly. We then get to the point where our app server farm has now exceeded capacity, and we're going to stick that in the external cloud as well, probably. But then we have a decision point. And I have talked, not scientific study, I'm not ADC DataQuest, but I've talked to dozens of Oracle DBAs and other Oracle customers, and in an Oracle context, I'm not talking about Facebook, MySpace, I'm not talking about that, but in an Oracle context, customers that are dealing with this kind of growth, those DBAs go, no way am I putting that thing out on the cloud. Forget it. I want control of my database environment. So they put it into an internal cloud. A lot of Fortune 100 companies that I'm talking to are doing this. They're creating a private cloud for their Oracle database environment and creating database as a service. Now, there's a couple of ways to do this. And it really turns out there's 2 competing ways to do it, really. Okay? One of them is with RAC. The other one is with a virtualization environment a la VMware. And for the purpose of this show, we'll focus on VMware. We'll start with RAC. So RAC, and Oracle will tell you, this is the way to do it, okay? This is what they will tell you. If you want to do database as a service, utility computing, whatever you want to call that, this is how you do it. You use something called schema stacking. For those of you who are not painfully technical in the database world, a schema is a set of objects which is owned by a user account. It can include table spaces, tables, views, blah, 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 blah. So what the DBA will do is take a particular project, a particular app that's sitting out on a database, and put that set of data into a schema and stick it into a monolithic rack environment. Now, a rack environment has multiple servers. Each server has its own instance, but they're all talking to the same database. And then we'll simply keep stacking in more schemas. Now, this does work. I have seen this work. There is no question. It works beautifully. It has some advantages. It is very fault tolerant. I have been in rack environments that have remained up for years with absolutely no downtime at all. It is also disciplined, which is another way of saying it is not flexible, right? So all of these projects are going into a single database environment. They have to be the same version of Oracle. They have to be on the same operating system. They have to use the same backup methodology, disaster recovery, remote replication. All of that has to be uniform. So that is discipline, and that is perceived as being an advantage because it, by virtue of being less flexible, creates a manageability advantage, which I'll talk about the opposite of in the VMware context. The disadvantage is, first of all, there's no built-in portability for these schemas. Once you've stuck that schema into that physical database, it's there. And getting it out is a manual process. It's not like vMotion. You cannot move these loads around across the various clusters in your environment the way we can in a VMware environment. Oddly, there is poor integration with the Oracle stack, by which I mean RMAN and DataGuard and things like that. A lot of these tools in the Oracle stack like to work on the entire database. RMAN, or they don't work any other way. DataGuard is the perfect example. DataGuard is a full-on database replication solution. You cannot replicate a table space. Okay? It's log shipping. You're replicating the entire database. So doing a failover of a single project, not going to work. You're going to fail over everything. RMAN is similar. RMAN likes to be backed up on a full database basis. Table space point-in-time recovery is possible, but no fun. It's also expensive. More expensive than VMware. So, that has the advantage of being extremely fault tolerant, and that's the position that RAC is in, as I'll show later. It is quite complex, and it is intense in terms of infrastructure. So it's heavy, big, massive type of infrastructure. Now we have true virtualization as the other cloud play. This is what I call VM stacking. So here we have physical ES6 servers and an HA cluster, and we start P2Ving our projects into it, striping the projects across each one of these servers. We can use HA cluster, we can use DRS cluster, and so forth. Each project has its own VM, has its own instance, and has its own database. Now this has a lot of advantages. Again, it has built-in portability. You want to move this VM from one cluster to another, or from one node in the cluster to another, you can do that. It's very scalable. You can get very high compression. It's not expensive. It's less expensive than RAC. It's simple and manageable. Oddly, again, although it's not the Oracle way, it provides better integration with the various Oracle tools. And it's quite light in terms of infrastructure. You can do this with fairly modest equipment. The disadvantage, again, it's undisciplined. That's the first one. What I call VM sprawl. If you have a mess, which I'll show you a mess later, we call that server sprawl. The mess would be, I have every conceivable version of Oracle possible. I have every possible OS. I have every possible backup methodology, disaster recovery methodology. Doesn't matter. I can P2V those as they are straight into VMware, and I end up with a mess in my VMware environment. I call that VM sprawl. Also, as I'll talk about in the clustering, it is not truly fault tolerant other than in the fault tolerance case, which is an edge case because only one CPU or one vCPU is presently supported, and I'll talk about that as well. So those are your choices. The way I like to think of this at the high level is this is the old database server. This is the fortress. All right? This is what DBAs like to build. It's big, it's heavy, it's expensive, it's very pretty. Don't get me wrong, DBAs love this. Okay? It's very pretty, it's very secure. But it's big, it's heavy, and it's expensive, and it's permanent. This is a cloud database server. Okay? It's a piece of tissue paper. I can use it and throw it away. It's ephemeral, it's lightweight. This is not true in all cases, but it's a very useful analogy. Looking at positioning, I like quadrants, as you'll find. All right, so this is availability up and scalability to the right. RAC is at the extreme high end. As I said, RAC is very scalable. RAC is very fault tolerant. You can keep RAC up for years, but it comes at a price. The price is going up as you go up to the right. At the low end, you have my MS Access, MySQL, and other toy databases like that. In the middle there, at the sweet spot, you have Oracle single instance with VMware HA cluster. I have said, and I believe it to be true, that 90% of all Oracle database instances that are running in data centers today could be run on an Oracle VM with absolutely no change in the user experience and probably a dramatic improvement in manageability and cost. That doesn't mean they are being run that way, but they could be. All right, so let's look at some common usage cases, and then I'm going to turn over the floor to Steve. So this is our complex test dev. Test dev is generally the place where you start. So here you have on the left your standard physically booted environment. Everything's physically booted. We have a big, heavy DMX. We've got your Oracle database environment with rack. We've got app servers and so on. We then replicate that using SRDF to our remote data site, and we decide we're going to create a test dev environment. So we build a cloud. We take that data set that we replicated and we snap it. I've seen it snapped up to 150 times. We could create 150 physically booted database servers and give each one of those to our test dev folks. That would be kind of expensive and fairly silly. You can simply create a bunch of VMs in a cloud using templates and then farm them out. That's an example of an internal database cloud. That's kind of the first step. This is the step where you don't want to put your Oracle database on production on VM. This is a more simple example. My group actually did this one. This is in a NAS context, believe it or not. And we have physically booted rack. In production on this one, we have the app and web tiers on VMware. And then we also did, using Solera Replicator, a remote replication and then created test dev on the target. So with that, I would like to turn it over to Steve, who will present the customer case study. This is Steve Tout with VMware. And the steps are this way, but you can jump. Excuse my coughing.
Thank you, Jeff. Hello, can you hear me? Can you hear me now? Thanks, Jeff. So it's a half-truth about my fear of you guys logging in during my talk. My boss said 15 minutes only. Last year about this time, there was about a 3x spike in customer registrations the weekend before VMworld. So that kept me a little bit on edge this year. So we have scaled out. We've added some capacity. No worries. We're doing really good. So today what I wanted to talk about is just looking a little bit at I've already identified myself, and Jeff has introduced me as well. So I'm a senior security engineer and identity architect at VMware. So what we wanted to talk about today is exactly how we're using Oracle data for the Oracle Identity Management Platform that we use. So the question kind of becomes, with the dev test refresh cycles that Jeff was talking about, what is the business really interested in, and what is IT really doing when we look at moving large volumes of data, in this case 2 LUNs and 168 gigabytes. When we're refreshing user data, we have this concept of a IT refresh or an environment refresh in our whole instance management program. So we want to refresh our user data back to a pristine state. We want to take that opportunity to deploy some new code and kind of spruce up the environment. We can apply hardware patches, hot fixes, do some infrastructure adjustments, and kind of reset our environment back to a pristine state, and also make sure we're bringing this environment forward with our patching strategy and keep it up to speed. So that's really a cycle that, as IT, we go through frequently in order to support multiple various initiatives going on throughout the year. One of the really big challenges that we face, and I hate to say this because I hear it so much, but in this economy, yes, that's true. We end up having so many more initiatives or requests going through IT. And either there's a hiring freeze, or your best system admin or DBA just walked out the back door for a better job. Who knows what it is? But frequently, even in VMware, we're asked to do a lot more with less and fewer resources. So by show of hands, who's a DBA in the room? Who's a system administrator in the room? It looks like we have a lot more system administrators. And I think, by the way things are trending at VMware, we're going to rely initially a lot more for implementing some processes and procedures at VMware with our system administrators. But as an identity architect, I'm frequently relying more on our processes and our tools and resources as we begin to, clone and get a lot of the best practices implemented and automated in our refresh. So what did we want to do? We wanted to really minimize and completely avoid a lot of the mistakes that were made with manual processes. We wanted to significantly reduce our build and refresh times to provide more flexibility to the business, be more agile in terms of the way we're managing IT resources. And I'm sure a lot of you here can commiserate with, we just really wanted to restore better work-life balance in terms of having, to be on call or on deck for a 12-hour shift at a time. Just kind of restore sanity across the whole team in terms of how much was expected of them to do and how much we could really rely on our tools and processes to refresh our Oracle data and even build our environment. So this was the VMware slide. I couldn't talk about refreshing Oracle data and EMC tools without also looking at, number one, how did the environment get here in the first place? And since this is VMware, I think the way that the environment got here is actually kind of interesting. So in response to some of the challenges and real key drivers that we had to improve our efficiencies and look at really driving changes by the way we build out environments and refresh our data in a totally, fundamentally, new and different way, we wanted to look at leveraging, cloning as a fundamental best practice for building out a new environment for the Oracle Identity Management Stack. Okay, so we had an initiative inside of VMware called NIM, the New Instance Management Project. So what we're doing here is building out Oracle Access Manager and from the database up, we're looking at cloning, automating the entire build of the environment. So we've taken a snapshot here of production. Jeff said there was a... So we have this template, and we just want to say we're going to take copies of these guys, and we're going to build out new environments here in the lower right-hand corner. Those are our NIM environments, and this just signifies that all three of these environments are going to be replicas of production. So that's our initial environment build-out. So on the automated refresh side, once we have the environment in place, then we can look at supporting the business through multiple initiatives and iterations by letting them just, beat the crap out of it, for lack of a better word. And once they're done with their testing, we can just repeat the cycle. We can go through, back out all of our application configurations that we can then later restore to that environment, and then we'll use some other technologies that we have from EMC, utilizing SRDF and Time Finder and a lot of the really cool DBA tools that they have. And they'll come and they'll just, using a block level replication, take everything that we have from a golden copy, whether that's straight from production or a golden copy, and we'll just refresh it right into our target environment. And then once all the data is copied, we have some other custom scripts that we use to restore the application configuration back into that target environment. So one of the really cool things about this is that initially we've really leveraged a lot of the learning and the knowledge of our DBAs and system administrators. But once we've really gotten this nailed down and implemented, it's automated entirely through PPM. So the next time I need a refresh in my environment, I don't need to go talk to the DBA. I don't need to go talk to the system administrator. These are all kicked off through PPM console. So as you can imagine, under the hood, there are some scripting jobs that are going on to kick off the backup of the application's configuration. And this is just looking at the levels of abstraction that we've made from the actual LDAP operations and bulk load or bulk delete commands that we have going on under the hood. And all of these interface with a success or a job completion status back to PPM. In the appendix slide, there is a pretty high-level diagram that shows you from end to end what PPM is doing. And this is really just from the identity and access management platform that I oversee and run at VMware. But you can draw your own conclusions. At VMware, we've seen in 15 times faster performance than some Oracle bulk loading and bulk deleting tools is a conservative estimate. Because when you utilize manual processes, it's really hit or miss. You're going to do a really extremely good job getting your environment refreshed, but the next time the database just might not want to behave so well. So you could spend an extra half a day, 3 DBAs later, trying to troubleshoot and fix a problem. So if you take that variable into consideration, we could save almost 36 times. It could be actually almost 36 times faster on the worst days. So all things considered, I mean, this was the kind of results that we were able to achieve with refreshing the Oracle Identity Management domain. But if we took a more strict accounting across the enterprise who are applying these same processes and same resources to build and refresh their environment, the cost savings and the time savings can really add up quickly. I see a hand with a question back there.
How much data is there and what's the latency?
The amount of data, there were two. For the Identity Management Suite, there were 2 ones and 168 gigabytes that we're moving for just this domain. The latency, the actual refresh, I think, is about 90 minutes. You're asking about the duration for the refresh? Oh, it's all in one data center. So I don't know what the actual latency is, but it's not significant. We could find that out and maybe pass it along later, but I'm not sure what the exact figure of that would be. So that's the case study that I wanted to share with everybody. There was links to more information if you were interested in that. One of the other, the very first slide I showed you was about the cloning. There's a more detailed discussion about how we've done the cloning on my blog at stevetout.com. And of course, you could check out the Alliance's website at VMware or EMC or talk to any of us, and we'd be happy to share more with you about that. Thank you.
I'm back on. Okay. So continue with our usage cases. Backup server is a really interesting one. In many environments, DBAs don't have a backup window. If you have a backup window, that's great. But 24/7 by 365 online transactional databases don't have a backup window. So how are you going to back it up? The way you can do that is a combination of your storage layer tools, in this case a snapshot, which is there, and a VM. Now, again, could you create a backup server for every single production database? Yes, you could. Physically booted, you could do that. It would be silly, Because why? I mean, a backup server, it's tissue paper. You create it, you run a backup, right? You mount your database onto the VM, you back it up, and you destroy it. You're done with it. That's the nature of a tissue paper cloud-style database. I call these utility database servers. These are non-production examples. Even in the Oracle space, this is not controversial. This is a very mainstream, normal type of usage for VMware in an Oracle context, right? Because there is no support issue here. This backup server is not a critical part of this production database. It's simply doing a job of backing up the database. In the process, it offloads all of the non-storage workload from the database server, thereby allowing that database server to continue to do the thing that it's supposed to do, i.e. parsing queries and executing SQL statements. So, another good example is a disaster recovery target. So there's a cost issue here. Without getting too technical, you can have a full-blown rack target. The licensing costs to do that are very high. Oracle actually allows you to run in failed-over mode with the same license as production. So you can save a significant amount of money on your Oracle license cost, which is a lot of money, by using a virtualized single instance data remote replication target. So right here you see that we have, go back. Okay, get the right button. We have Recover Point. We're using my personal favorite remote replication tool. We're replicating across a WAN. When we get to the DR site, we're using a single instance virtualized database here. We are taking a bookmark and mounting that. We could also, and I don't show it here, but we could be using DataGuard. Okay? You could do this whole thing without Recover Point, just use a normal WAN, use log shipping, and on your single instance virtualized database server on the target side, apply the logs. It doesn't take that much horsepower to apply logs. Okay? There's no significant SQL going on there. So that's a very mainstream, again, non-controversial usage for VMware. The remaining stuff, admittedly, is a little bit more edgy, but the benefits are extremely high for this type of environment. So I call this software as a service, lighthearted graphic there, providing service. So a good example that I like to use here is I have a customer in North Carolina. They create a software package that is for managing of hair and nail salons. And they will provide you with everything that you need to run your nail or hair salon other than the actual product and service. So personnel, payroll, scheduling, inventory, ordering, everything. And they sell this product as a software service over the internet at trade shows where nail and hair salon people go. So what they want is they want to be able to sit down with a customer at the trade show and sign them up, and within a very short period of time have that customer be in business. And using this approach, they're able to do that. In a rack context, it would be more difficult, right? So what they're doing is they literally take each customer and spawn them a set of rack VM, or a set of VMware VMs, representing the database and app server for that customer. And they can do that in a matter of minutes, literally. So the essence of software as a service is, number one, all rows do not have to be seen by all customers. If you don't have that, you don't have software as a service. Right? In this case, in fact, each customer must not be able to see the rows of any other customer. Right? Each customer is completely independent. You need to rapidly provision servers, and it's completely automated. Those are the three requirements for software as a service. For that, VMware virtualization works beautifully. Another usage case I talk about, again, this is production. Can't mention the name of the company, but there is a Fortune 100 company. They have a data center in a major metropolitan area where they have 824 single instance, individually, physically booted Oracle database servers. The cost of managing this set of servers for this customer is $228 million a year. Now, why did they do that? This customer was at one point very, very wealthy. They created this environment where effectively the CIO told each group that was going to solve a business problem, here's a business problem. You go solve that problem. Here's a budget. Go buy equipment. Solve it. The means whereby you do that are yours to choose. So they ended up with every conceivable version of Oracle, every conceivable operating system from Windows, SUSE Linux, Red Hat Linux, Oracle Enterprise Linux, da-da-da-da-da. All kinds of various extraneous tools, SQL Backtrack, RMAN, Networker, Net Backup, blah, 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 blah. No discipline at all. This is, again, where we can get into VM sprawl. The quickest path for this customer to reduce their cost is to V2P these environments. And what the customer is doing, in fact, is a mixture of the P2V and schema stacking, which I described earlier. So some of these projects are going into rack environments, and some of them are ending up in a VMware cloud. All right, so those are the basic usage cases where Oracle works well in a VMware context and makes sense to use a cloud. I'll now talk about some best practices and implementation guidelines. This is the kind of the good, the bad, and the ugly. So let's start with licensing. All right, so here's a 4-node VMware HADRS cluster. And you see here we have Oracle interspersed with SQL Server and Exchange on the same physical boxes. Now, the way Oracle is licensed is on the physical CPU. If Oracle code is running on that CPU, you owe Oracle money. And Oracle does not count a vCPU. So if Oracle is running on that box, again, you owe Oracle for every single CPU on that box. The result of that is big bucks. All right? So don't do that. This is bad. Very, very naughty. That's what you want. So what we've done here is we have isolated the Oracle software from the Microsoft or whatever software in a completely separate failover cluster and DRS cluster domain where no Oracle code is allowed to run on a box that is running any other workload. That saves big money. In fact, compared to a physical environment, that will save you so much money that it will easily pay for the entire cost of the project. The first one will waste money. All right, so that's what you got to do. Shameless plug here for PowerPath. PowerPath VE came out recently. It's awesome. Okay, that's the bottom line. Don't use any more of the built-in VMware ESX multipathing if you're in an EMC environment. Go buy PowerPath VE. It's great. It provides dynamic load balancing across iSCSI and SAN environments. It's very reliable. It's awesome. Okay? That's the bottom line with that. Okay, so this is my HA cluster slide. Again, let me just position this. So the whole point of this slide is, and I think most of you know this, an HA cluster failover event results in the reboot of a VM. Okay? Now, from an Oracle standpoint, that's called downtime. It's not a lot of downtime. It's a couple of minutes of downtime. Again, 90% of the Oracle databases that are running in data centers can withstand that. But the 10% that can't don't belong on VMware. If your database has hard legal requirements for real-time access with absolutely no provision for downtime, put that sucker on rack, okay? Because that's where it belongs. All right. I get asked this question a lot. How much compression can I get? This is my non-scientific response to this question. On a database server, you can get, on the low end, 4 VMs per ESX server. That would be a pretty beefy server. Okay? That's like a 16 CPU or 16 core server. Each of those database servers or VMs would have 4 vCPUs. And that's what we test with at EMC. If you look at any of the white papers that I authored that are showing up on PowerLink, those VMs have 4 vCPUs apiece. Likewise, you'll see a lot of memory, and I show this in the next slide. Right? So a high end would be 10. For example, the customer that was here last year, the United States Air Force Bonfire Project at Hill Air Force Base in Utah, they're getting 10-to-1 compression of database servers. But their database servers are more lightweight. All right, so I'm running heavy transactional OLTP workloads on these database servers, and I'm getting about 4-to-1. App servers, you can get better compression from 10 to 30, and web servers you can get from 30 to 50. Here's the CPU. All right, so I'm showing a database server versus a typical, again, my unscientific, but I think reasonable estimate of what you see. I have 4 vCPUs per database server, 16 gig of RAM. On an I/O basis, this is a relative amount, but I am showing about 5 times as much I/O from a database server as I am from a typical VM. Database servers do a lot of storage I/O. There's no way around that. OLTP does a lot of random small block I/O, and data warehouses, which it's questionable whether you would put a data warehouse on a VM, but those do even more sequential large block I/O. And then network. Database servers in the OLTP context return a lot of data to the client. They soak up a lot of network relative to a standard VM. One aspect of this, okay, so an Oracle database server has a very large structure in memory called the System Global Area, or SGA. That is the majority of the system memory for a VM. That is being very heavily updated. I've seen vMotion times of up to 20 minutes for moving an Oracle database server that's encountering heavy transactional use because of the memory access that's going on. You know how VM works. You move memory blocks and maintain a bitmap of the dirty memory and then repeat that process and repeat that process. That can be a long time. So you need to bear in mind when you do a vMotion, it's not going to happen as fast as you're used to with a regular VM. SAN and NAS. Okay? So here are 4 ways, and these are, by the way, the only 4 ways that I know of, not including iSCSI, which I don't really cover iSCSI for reasons that I'll be happy to discuss offline for anybody that's interested. This is an NFS direct mount. By that, I mean that the NFS export has been mounted directly into the VM via the VM OS's VMFS file, or FS tab. That is what I call the NFS direct mount. The second example is NFS that is mounted onto the ESX server, and then VMDK files are created, which are used by the VM as disk. Now you see the difference between those two. This is 95% and this is about 67%. The effect of that is highly inefficient. All right, so I only use this type of access for the OS image for the VM to boot. Do not store your Oracle database on VMDK files that are mounted on an NFS mount on an ESX server, because your performance will be terrible. Okay. Also, the other option, okay, I should point out the fiber channel, and this would also include iSCSI if you wanted to do it via iSCSI. This is ASM via RDM. RDM is raw device mapping. And then ASM via VMFS with VMDK files. All right, so it turns out the overhead for VMFS is only about 2 to 3%, according to our testing. But there are a couple of reasons why you would want to use RDM. Number one is it will facilitate P2V and V2P. So obviously having ASM sitting on a raw LUN will allow you to move that ASM onto a physically booted environment should you need to do that, whereas having it sitting in a VMDK file inside of a VMFS file system will not. The other is that some EMC utilities, notably Replication Manager, cannot discover the LUNs that represent an ASM disk sitting inside of a VMFS file system, but they will discover raw device mapped LUNs just fine. So if you want to use Replication Manager with your VMs, which by the way is a really good tool, shameless plug, then you'll have to use raw device mapping. So in conclusion, we start with unified storage, of course, and we're on our march to step-by-step the virtual data center. And here's the benefits that we achieve: improved utilization, which is, after all, the point. On a typical Oracle database server, according to VMware, the utilization is way less than 10%. That is the most expensive CPU in your entire configuration. If you can get that up even to 50%, you've saved 80% of your cost. That reduces your TCO. You get simplified management, and that gets us to questions. Let me check my time. Perfect. Question in the back. Go ahead.
You were going over the Oracle licensing and the idea of breaking out into separate clusters.
Yes.
What have you heard from Oracle around their anticipation of how host affinity is going to affect their licensing scheme?
So the question was, what have I heard from Oracle
on the microphone, please?
with respect? I'm sorry?
Could you have people ask their questions on the microphone for the recording?
Okay. Yeah, that would actually help me. So come up and ask the question from the microphone, because I don't think I completely understood the question.
So with the introduction of host affinity, is that going to impact Oracle's licensing scheme? Will you have to separate out completely different clusters, or will host affinity be enough to control?
Okay. So the question was whether or not the implementation of host affinity will impact the Oracle licensing scheme. I have heard some rumblings around Oracle circles concerning some changes in their licensing to get away from their honestly fairly archaic way of licensing, including allowing for virtualization. I don't have any hard information about that, unfortunately. I apologize for that, but that we simply don't know yet. I don't know if they even know. Any other questions? Oh, come on. Here. I got a question right here. Yes. Okay, the question was, what about data warehouses on virtual machines? All right, so a data warehouse, by definition, if it is a true data warehouse, is a very highly scalable, intense environment constituting terabytes of data. Actually, I was involved in one data warehouse at, I can't name the customer, but it's a major internet search engine provider that was 5 petabytes. Okay. Those environments are going to need 100% of the capacity of any reasonable server that you could buy. So the question you have to ask yourself is, given the fact that I don't have the opportunity to partition the server up and make something smaller than the entire box. If I need the entire box to do this workload, does VMware buy me anything? So for that reason, I don't see VMware being, at this point, a very interesting play for data warehouse. That's my take. Okay? Question here.
So how much does limitation of 8 vCPUs per SOS inhibit you from doing large local databases with high increasing errors?
So the question was, how much does the 8 vCPU limit impede the ability to manage a highly transactional Oracle database environment? Is that the general gist? Yeah, all right. Not very much. Okay, again, looking at the quadrant that I put up where Oracle Rack is at the top right, so Oracle Rack can scale very high and has a lot of availability. Those are its two advantages. If you need something that big, then Rack is your play. But there are an enormous number of databases that don't need that. Even in the context where you have that environment, the test dev server for that environment doesn't need it. Right? So your production may be sitting on a 4-node Oracle Rack, and that's fine. But your test dev environment for that same environment can be on a VM, as well as a whole galaxy of other things. It's very similar to the SAN versus NAS debate. I see VMware right now as being very similar to what NFS was in the late 90s and early 2000s, where people went, do I really need a big, expensive SAN environment for my test dev? Or for my, small utility server, for my data warehouse staging, data mart, summary calculation, a whole host of things get done with this data that is not primary OLTP transactional stuff. And for that, your VMware environment works, right? Does that answer your question? All right. Any other questions? Yes, question here in the back.
Back to the Oracle licensing, which seems to be one of the biggest roadblocks for us. Obviously, all the CPUs and the hosts running the Oracle software have to be licensed. That makes sense. Or I guess a little fuzzy for us is when you fail over, whether you're in a VRS cluster or whether you're replicating. If you just fail over, well, you have all your Oracle CPUs in the VRS cluster, you probably have them all licensed. But if you're replicating to another location and you want to bring it up, I'm assuming because you're replicating, you have to have another location, the binaries are there, even though you're not running it, you have to license those CPUs.
Oracle's position, the question was on specifically, and I'll kind of, I think, summarize your question, and I had a debate with Oracle on this exact question. If I am replicating the Oracle binaries to a remote location, do I have to pay Oracle for the license fee for the CPUs where that replication is occurring? Is that your question? I'll also cover the licensing part, but let's cover that first. Oracle's position is yes. Anytime that the Oracle software is being replicated, by the way, I disagree with this. Okay, I'm an attorney. It's a flaw in my character that I've struggled to overcome. I think on most days I'm pretty good. I still am prone to bouts of argumentative pedantry, arrogance, the other aspects of attorneys. But in this case, I'm going to be argumentative and say, I disagree with this, but Oracle's position is that you owe them the license. My position would be, you owe them the license if the software is running, you actually have background processes on that box. But that's not Oracle's position. So I think likelihood is very strong that you will owe them the money. Getting to your first question of whether or not licensing is a roadblock, I take the exact opposite approach. I think that licensing is awesome for VMware. Okay, what is VMware really for? What is virtualization for? It is to improve the utilization of a server. Now, VMware has done studies using Capacity Planner runs that have been done in various customer locations. They have 70,000 of these runs, and Capacity Planner will go out there and he will look at every server in your environment, and he can tell what's running on those servers. And this was covered, by the way, in a presentation last year at VMworld, and probably they'll present this year as well. I apologize, I don't know the presentation, but go find it. At any rate, what they found is that these typical Oracle database physically booted server is running at about a 7% utilization. Now, Oracle is expensive. It's a high-end tier 1 application, right? And it's priced on that CPU. So you are wasting 93% of that CPU. If you can take that utilization up to even 50%, which is not hard, you can save the vast majority of your Oracle license cost, which is a lot of money. I mean, that $228 million that I talked about from that Fortune 100 company, almost all of that is related to Oracle licensing and maintenance costs, which are all priced on the CPU. All they're trying to do is get their CPU up. So that means, and particularly with the way Oracle is licensed now, that you have the opportunity to save a lot of money by using VMware. That's really the value proposition. Does that answer your question? Okay. Any other questions? Thank you very much for coming. And enjoy the show.